Okay, welcome back. This is Mr. Hassan's Maths channel, and I'm now going to be answering question number 4 from the International A-Level Edexcel Statistics S1 paper from June 2019. Okay, so this question number 4 is about normal distribution. It says that the weights of packages delivered to Susie are normally distributed with a mean of 510 grams and a standard deviation of 45 grams. So the weights are such that they are normally distributed with a mean of 510 grams and a standard deviation of 45 grams, so 45 squared. I'll just leave out the grams here. Okay, 510 is the mean and 45 is the standard deviation. So this is how you write it. This is the variation here, which is the variance, sorry, not variation. Variance here, which is the square of the standard deviation. That's how the standard way of writing it is. Okay, it says find the probability that a randomly selected package delivered to Susie weighs less than 450 grams. Okay, so I'm going to draw my normal distribution curve here. Okay, so here it is. And what I'm going to do now is first of all, we know that the mean is 510, so that's the mean. And it says, find the probability that a randomly selected package weighs less than 450 grams. So 450 grams is below this. Okay, it's below this mean. Okay, 450 grams will be over here. So it's below the mean. Okay, so we want to find out the probability that it weighs less than that amount. Okay, so this is 450 grams here, and we want to find that something, we want to find the probability that it weighs less than 450. So we want to find this probability here. Okay, so what we can do is we can go to our tables for normal distribution and we can find the value. So first of all, we need to standardize this value. We want to find out how many standard deviations below the mean 450 is. Okay, that's what we need to do, because our table for Z values, which we're going to look at in a minute, tells us about the value of Z as, you know, how many standard deviations above or below the mean it is, and then you can work out the probabilities. So we want to find the probability, okay, that the weight is less than 450 grams. Okay, and that's equal to the probability that Z is less than, now to standardize this score, okay, to get the standardized value, the Z value, you take the score that you want to standardize, you take away from it the mean, and you divide it by the standard deviation, okay, which is given the symbol sigma. So here you're going to have the value that we want to standardize minus the mean, which is 510, divided by the standard deviation, which is 45. Okay, and that will tell us what Z value to look at on the table. So we want to find the probability that Z is less than. Now if we put that in our calculator, okay, we're going to have 450 minus 510 divided by 45, and that gives us minus 4/3. So that's minus 1.33. You know, that's the value that we'll be looking at. There's only two decimal places in our table, so 1 minus 1.33, continuing on. All right, so that's what we have to do. Of course, the Z value here is below the mean. That's why it's negative 1.33. Now the problem is our table of values for Z, which I'll show you here, okay, do not include Z values which are negative. Okay, they start at 0. So basically the Z value starts from 0 and it goes this way. Okay, we don't have a negative 1.33. If you want to find negative 1.33, this phi Z is the area to the left of the Z value given here. So we know that the area to the left when Z is 0 is 0.5, is half the area. The area to the left when Z is, for example, 1.5 would be here, would be this area over here, which is 0.9332. Okay, that's the probability that something's less than the Z value of 1.5, for example. But we want to find the probability that Z is less than minus 1.33, which we can't find from this table directly because we don't have Z values which are negative. So what we got to do is we got to go to Let me try and be a bit neater than that. We've got to go to 1.33, okay, which is like it's symmetrical for minus 1.33. It's exactly like symmetrical here. So this is 1.33, and I know that the probability of something lying in this region is the same as the probability of something lying in that region. Okay, now I can find 1.33 in my table. It's right over here. 1.33 is over here. 0.9082. What that means is, this is the phi z is the area or the probability of something being less than that. I want the probability of being more than that. So if I can find this area over here, I can find this value over here by looking at the table. And if I can do 1 minus that area, I'll get the area I want, because the total probability is 1. The total area under this curve is equal to 1. So if I find the area from here all the way to there, okay, and I take that away from 1, I'll be left with the area I want. Okay, so that's basically what we're going to do. So let me take the value for 1.33, and we'll use that on the other side. So we get 1.33, which is over here. I'll take that value and we'll then work out what we need to work out. Okay, so the probability that z is less than 1.33, which is over here, which is symmetrical to that. Okay, this is say 1.33. What we've got here is the area between this region all the way back down to there, and that is 0.9082. What we want is this area here. It's the same as the area that we want. So what we can say is our area, the probability that z is less than minus 1.33, is equal to 1 minus the probability that z is less than 1.33. Okay, because it's the same as the probability that z is more than 1.33, which is this area over here. Okay, this is the area that we want. So 1 minus the probability that z is less than 1.33 is what we need. And this is the probability that z is less than 1.33, 0.9082. So you have 1 minus 0.9082, and that will give us our solution. So you have 1 minus 0.9082. Okay, let me just make sure I wrote that correctly. Yes, 0.9082. So that gives us a value of 0.0918. 0.0918. So that is our solutions to 3SF, so we should leave it like that. So we can say the probability that the weight is less than 450 grams is equal to 0.0918. Okay, so there's the answer to part A. Okay, now for part B. Part B says the heaviest 5% of packages delivered to Susie are delivered by RAP. So remember, the weight is such that it's normally distributed with a mean of 510 and a standard deviation of 45. That was correct. That's right. Okay, so the heaviest 5% of packages delivered to Susie are delivered by Rav in his van. The others are delivered by Taruni on foot. Okay, so let's get our curve again. Okay, so the heaviest 5%. Okay, so the heaviest 5% would be somewhere over here, such that this area is 0.05, and this area will be, of course, 0.95. The area all the way from there to there. So we know that the mean is 510. We want to find out what this value is here. Okay, so we know that the probability that z is greater than x is equal to 0.05, and we want to find what that value x is. We want to find what that z value is here for this particular area being 0.05. Now, as this is a nice, easy, this is a kind of like an exact, almost exact type of value of the area, it's possible that this answer is found in the other table that we have. So let's go back to the tables. We have two types of table. One table tells us the value of z and the area to the left of it, and the other table in our formula sheet tells us the value of the area and the area to the right of a particular Z value. Okay, so if we see the two types of table, we have this table here where you have the value of Z, and this is the area to the left of that value of Z, and this tells you the value of the area. P is the area, and this is the area to the right of these Z values. Okay, to the right of these Z values. So we need to find an area of 0.05. This is 5%, 0.05. Okay, so we can see that that value is in the table. All right, so basically what this means is that in a standardized curve, that if this area to the right of this is 0.05, then this Z value is going to be 1.6449. So we've got the standardized score for any bell curve where the area is 5% to the right of it. Okay, so we can use this instead of going here to look for the area of 0.05. I mean, you could do that. We could go to 0.0. In fact, we'd have to go to 0.95. Okay, because we only have here the areas to the left of stuff, not to the right of stuff. So you have to go to 0.95. You have to go down to here. The closest to 0.95 would be something like this, and you'd use the Z value of 1.65. Okay, which of course is the same thing, that almost the same as what you get here, but this is more accurate. So if you're able to use these values here, always use this table. So if it gives you, if you're given a value like 0.5, 0.4, 0.3, 0.2, 0.1, 5.1, any of the values that are here, this is the area to the right of that particular Z value, then that's what you should use. So I'm going to use this value over here, and I'm going to find what we need to find from that. Okay, so we have the Z value here is 1.6449. Okay, so this is 1.6449. So now we have to basically, you can say that undo the standardization. So we know that Z is equal to X minus the mean over the standard deviation. That's how you standardize a score. Now we want to, we want to reverse the standardization and find the actual score for which the value of Z is 1.6449. So what we're going to do is, we know the Z value is 1.6449, and we want to find the score, the actual weight that's going to be here. So we take away the mean, which is 510, and divide by the standard deviation, which is 45. Okay, so if I undo this, I multiply by 45, the standardized score, 1.6449, and I add to it 510. That's how I make X the subject, and that will give us the actual standardized value. So you have 45 times 1.6449, add to that 510, and that gives us 584.0205. 584.0205, which is 584 kilograms to 3. Is it kilograms? Sorry, it's not kilograms. That's a bit heavy. Yeah, grams. It's just a package. Okay, 584 grams. That is the lightest of the packages that Rav will deliver to Suzy, because he delivers the heaviest 5% of the packages, and the boundary for that is this 584 grams. Okay, so that's the weight of the lightest package that Rav would deliver to Suzy. Okay, it's the start of the top 5% of the heaviest packages. So that's part B done. Now we're going to move on to part C. It says Suzy randomly selects a package from those delivered by Taruni. Now remember, Taruni was the one that delivered the lighter packages, the ones below this value. Okay, the ones that are less than 584 grams, those are the ones that Taruni delivered. Okay, and so let me just take this here again. I'll take this and this, but not that. I'll just take this. Okay, put it over here. All right, let's get rid of some of these things here. Okay, so Taruni delivers the heaviest 5% of the packages. So Taruni delivers, okay, between 584 onwards. So that's an area of 0.05. That's the area, that's the percentage that Taruni delivers, 5% of the packages, which is the heaviest 5%. And that's RAV, sorry. Taruni delivers all the other packages, okay? All the other packages which are less than that. So that total area that Taruni delivers is 0.95. Okay, that's the percentage of the packages delivered by Taruni. That's a percentage delivered by RAV. Okay, you want to find the probability that a randomly selected package, okay, from those delivered by Taruni only weighs more than 450 grams. So you have a condition here. The condition is that they must be delivered by Taruni, not by RAV. So it's not just the probability that the weight is greater than 450. No, it's not just that. There's a condition. So what we're trying to find is that the probability that the weight is less than 450 is greater than 450 given that it's delivered by Taruni, which means the probability that the weight is less than 584. Okay, that's what we have to find. It's a conditional probability. So we're finding the probability that the weight, how do we write this? Sorry, you don't write it like that. We want to find the probability that the weight is greater than 450 given that the weight is less than 584. Okay, so we have to only choose from these items, the ones that are delivered by Taruni only. So we're only considering this highlighted region here. Okay, we're not considering anything else. So that's what we're choosing from. And we want to know from this region the probability, or that it's within this region here. So our sample set is the yellow area, which is the weight is less than 584. That's what we're choosing from. We're not choosing from the ones above here, only the ones that Taruni delivers. And we want to find the probability that from those, the weight is between these two values, between 450 and 584. So I need to find this area here, okay, between 450 and 584. Now I already know that this area over here, we found it in the first part of the question. Okay, this area over here is the same as the area over here, which was 0.0918. That's the area over here. So the whole area between this value and that value, this whole area here, okay, is 0.9082. Okay, so the whole of the yellow area, which is the probability that the weight is, this area over here is 0.0918. This is the area in this section here. Okay, and the area below 584 is 0.95. Okay, so this shaded area over here, area over here is going to be 0.95 minus 0.918. So first of all, when you have a conditional probability, like the probability of A given B, you always have the probability of A intersection B over the probability of B. So A intersection B here would be this region that I'm mentioning now. So A intersection B here is basically the area that I've shaded over here. So as I said, this is from 584 below is 0.95, and this region here is 0.0918. So what we can do is we can say that that shaded area is 0.95 minus 0.918, and I've got to divide that by the probability of this whole region here, which is 0.95, and that will give me the answer. That will give me my answer. Okay, so the answer is going to be given by 0.95 minus 0.0918, sorry, that's 0918, okay, divided by 0.95. Okay, and that gives us 0.090336 0.903, what was it? 0.903368. 3368. If you round that to 3SF, you have 0.903, and there's the answer to part C. Okay, so I hope that was clear. We're trying to find the probability that a package delivered by Taruni weight is more than 450 grams. So we already have the figures that we need for this. So basically, you're only considering the ones that are delivered by Taruni, which is 95% of the packages. That's the sample space. So that's why you have the probability underneath of 0.95, because that's the sample space. That's what we're looking at. And we're trying to find the probability that it's greater than 450. So we need to find the region, the area here. Within this, within the sample space that we're looking at, we look at the area that we need, which is between 450 and 584, and we already know that this area here is 0.0918, and the area below this is 95%. So 95% minus 0.0918 will give us this shaded area. So it's that area over the total sample space which gives us our answer. Okay, now on to part D. Okay, so part D states that on Tuesday there are 5 packages delivered to Susie. Find the probability that 4 are delivered by Taruni and 1 delivered by Rav. Now remember, the ones that delivered by Rav are the top 5%. So the probability that it's delivered by Taruni, let's say, is equal to 95%. 95% of the packages will be delivered by Taruni, and the probability that they're delivered by Rav is going to be 0.055%. Okay, so that's the breakdown of the ones that are delivered by Taruni and Rav. Now, you've got 5 packages, okay, and 4 of them, we've got to find the probability that 4 of them are delivered by Taruni and 1 delivered by Rav. Now, there's different ways of doing this, okay. You know, I mean, if you just list them all, that's one way, but I'll show you a quicker way in the end. But basically, just imagine you did list them all. You have, just say you got Taruni, 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 and Rav. Okay, so you'd have basically the first is delivered by Taruni, and then the second. So you have 0.95 times 0.95 times 0.95 times 0.95, which is 0.95 to the power 4 times, and then you have the last one delivered by Rav, so that's 0.05. But there are other combinations as well. It could be that this is where the first 4 are delivered by Taruni and the last one is delivered by Rav. You could also have it as T, 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 R, and T. That's also another option. But they will have the same probability as this, because you've got 4, you're going to multiply T, the 0.95 by itself 4 times, and then 0.05. But there's also another probability, which is T, T, R, T, T, okay, which again will be the same values here, but just another, outcome. All right, so you have 1 outcome, 2 outcomes, 3 outcomes, 3 different outcomes, okay, but they all have the same probability, each of these outcomes. Then you can have T, R, T, 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 and also you can have R, T, 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 T. So you can see that there are altogether 5 outcomes. So you've got to take this and multiply it by 5, because you've got to take each of these outcomes and add them together. If you were to do a probability tree, that's exactly what you'd get. Okay, you'll have, for example, T, Taruni, or Rav. So you're trying to find that that 5 of them are delivered by 4 of them delivered by Taruni, and then 1 by Rav. So you're going to have this, 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 and this. That's 1 outcome. And then you'll have altogether you'll have 5 outcomes which have just 1 R in them, and all the others are T's. Okay, you don't have to do this tree. That tree will be complicated. But there's a very simple way of also doing something like this. If you want to choose, or you want to see how many different combinations you can get of one item, okay, when you have, for example, 5 items, and you want to, see how many ways of arranging 4 of them from those 5 items, or you can do even this. There's 1 out of 4. You want to choose 4 out of 5 or 1 out of 5. This will also give you the answer. This is called the combinations button. Combinations button on your calculator. It's the NCR button on your calculator. Basically, what this will do, this will say you'll have 5 factorial over, and then you have this number, which is 4 factorial times 1 factorial. Okay, or if you do it this way, 5 factorial over This is 1 factorial times 4 factorial. It'll be the same thing. So in this case, it's 5 times 4 times 3 times 2 times 1 over 4 times 3 times 2 times 1. That will leave you with 5. Okay, and this will also leave you with 5. Okay, because you have 5 times 4 times 3 times 2 times 1 over 4 times 3 times 2 times 1, which will also be 5. So in either case, you're going to get 5, of course. But this is how you can quickly find the number of combinations. So for example, supposing it said, find the probability that 2 are delivered, the probability that 3 are delivered by Taruni and 3 by Rav. Okay, so you would have, alright, you'd have basically, there's 5 being delivered altogether, and you want to see that 2 of them are delivered by Rav. And that will give you, okay, the answer. And your calculator will give you the answer. You got the NCR button, which is this button over here. So what we did was 5C1. So we can do 5C1. That's when you have one item out of 5. You want to see how many ways you can arrange it. You can see there's 5 ways. If you had, if we did 5C4, because it's also, you can think of it as there's 4 items we're arranging out of 5. It gives you the same answer. If there are, 2 items that you want to arrange out of 5, you'll see the answer will be different. There's 10 ways. So, I mean, I'm just digressing here. This is not the answer to this is nothing to do with our answer. But supposing it was 2 R's and 3 T's, then there would be more ways of arranging them. Okay, there will be more ways of arranging them. And this button helps us to find how many ways. There will be 10 ways actually. But this will give us the answer that we're looking for. So let's just put that in now. I just went off the tracks a bit just to explain. So 0.95 to the power of 4 times 0.05. Okay, and there are 5 ways of 5 different combinations of that probability. So your answer is 0.2036 0.20362. It continues on like that. We are only concerned about the first 3 significant figures. So the answer is going to be 0.204. And there is our answer for this question, part D. And that is the end of the question number 4 from this paper from June 2019. Thank you for watching. This part D was actually requested specifically by a student. So I hope that's why one of the reasons I went into a bit more detail. So I hope that was clear and understandable. And if you want to see other questions from this paper, which I'm going to be completing within the next few weeks, then you can look at the playlist, which should appear over here. If you want to see other questions from this topic of normal distribution, you can click on this link over here. You want to subscribe to my channel, you can click on the icon over here, and on the top of the page will take you to other S1 papers you might want to watch. If you're interested in looking at the other AS or A2 papers, International A-Level P1, P2, P3, P4, M1, then you can go to the description below the video and check out the links there. Also, there's IGCSE material that you could access from there. Thank you for watching and see you soon.